good morning, season, temperature or day. My name is TrackLab, welcome to the Bragging Show. We write the year 3 o'clock, it is a time full of AI. So many geniuses that are able to create super complex models that can complete images, synthesize voice, drive cars, and here I am creating an emotion predictor and other tiny projects. You clicked on this video, probably because you saw the title and thumbnail talking about the emotion predictor, or maybe you just misclicked and you actually wanted to see more of the slow-mo guys. Well, now that you're here, let me tell you a story. A story of a simple person that wrote the motion predictor in the title, but is gonna talk about completely different things first. And Chen and I were working on a much bigger project that just takes a little bit longer than expected. I don't want to tell you too much about it, so all I'm going to say is that this project is something you will be able to use as well. And there's a high chance that you actually want to use it, but more on that when it's done. Since the big project takes longer than we thought, I came to the decision to give you guys a video about my recent smaller scripts. When you know how to program, you can easily create software directly focused for the purpose you need it for. There's not always a pre-made program for exact problems you need to solve. For example, I needed a way to quickly crop a lot of images to the same size. How would you do this if you have 5 pictures? You would probably put them in GIMP, crop them and export them. Sure, with 5 files, that's alright. But how about 500? Would you still put those in GIMP? Probably not. So what I did was creating a simple Python script that takes all images in a folder, crops them to the same size and then exports them again into another folder that I specify. The script works by starting on the first pixel of the image 0, 0. Then it goes to the pixel that I specified and crops everything of the image that is outside of these boundaries. For the image set that you saw, I used the size of 384 by 384 pixels. If the image happens to be smaller than 384 by 384, the script fills the missing area with black. And in less than a few seconds, you got yourself a nice new folder full of all images in the same size. Couldn't be easier. Try to do the same thing with GIMP manually and let me know how long you need. Pretty sure my script is faster. Another problem I faced recently was a directory filled with files, which is definitely unusual. MP3, MP4, PNG, JPEGs, THJs, text, access and so on, you get the idea. I wanted to get rid of all PNGs, JPEGs, text and TGAs without deleting every other file type in the folder. Now what you could do is sort the files by file type and then delete all PNGs, JPEGs, text and TGAs manually, but I'm a programmer. I know how to make little scripts. I don't need this manual shit. So you write another Python script that asks for the file types you want to delete and then it goes through the whole directory, deleting every file type with the file type that you specify to delete file type. File types are everywhere. Not only is it faster than doing it manually, obviously, it is also a lot easier in my opinion. A third script I did was something I call random chaos. It is nothing useful really, nothing like the 2 scripts before. What I did was using Pygame and random number generation to create rectangles in random size, location and color. Running the random creation in a loop without the screen clear function, I ended up with a pretty trippy looking program. Could you use this as a background? Not sure. Some people may have problems with all of those moving rectangles. I don't, so it exists now. The fourth and last small script I did recently is a key presser. There are Python modules that are supposed to virtually press keys, but they mostly do not work inside programs that are not the desktop. For example, games. So if you want to do a program that can press keys inside the game to, I don't know, learn how to play it or just do anything, it won't really work. Someone on Stack Overflow made a piece of code that is able to do exactly that. That code makes the PC think you actually press the key on your real keyboard, as real as this one over there. The source code is heavily hacky. You need to look up the hex codes for the key you want to press and you need to reference them every single time. Also have to tell the script to stop pressing that key after pressing it because otherwise it's just gonna hold that key forever. So I changed the entire script by a whole bunch. Now it has an easy to access key hex code list, a simple press key function, and now you simply have to call that function. You give it the key you want to have pressed as string and you're done. No need to look up hex codes, no need to remember variable names. All you do is give the function the exact key you want to press, that's it. So if you want to press W, you just call the function and tell it I want W. And that's it. This is great for all sorts of things. Automatic writing, an AI playing a game, or a loop that makes you walk in circles in GTA to not get AFK kicked. I'm not saying I did last, I'm just saying you can do that. That's not what I wrote the script for. Now that the less interesting scripts are out of the way, let's take a look at the thing that is actually promised in the title. There are apps that let you document your emotional state each day to find patterns of what makes you feel bad or good. Some of these apps even let you export the recorded data as a CSV file, perfect to use for AIs or general data sciencey. You basically can see how you felt in the past, which can be pretty neat. You can figure out how you maybe can improve stuff, you can figure out what made you feel sad, you can even see how you felt. It's just interesting to see. But how about an AI that predicts your emotion in the future? Before I talk about my approach, let me explain a really simple difference. The way you can make prediction about something is either by time series data or by feature sets. In time series data, all you have is the recorded dates and the corresponding numbers. This can be house prices over a certain period of time, or the emotional state over the last few days or weeks, or the amount of players a game had, or I don't know how many people watch my videos. It can be anything. Any number related thing over a period of time. In feature sets, you got several features about the object you want the number for, or actually classification. Because time series data is regression problems and feature sets are usually classification problems. So one is regression, one is classification. If you don't know the difference, it's not too complicated, no, it's not too important. For example, you want to predict a house price based off its size, location, quality and the neighborhood. You got 4 features there. And of course also the house prices that go with all of those features. Then you let the AI predict a new price from a new house with different size, location, quality or neighborhood given. So either you predict into the future based off historical time series data, or you predict a new object with comparable features based off a feature data set. So about my AI. What I originally wanted to do was an AI that predicts my emotional state in the future. For something like this, you would use time series data or regression, but I didn't because I don't know how. Instead of doing time series data, I used a feature data set to predict the emotional state. That data set records the current weather, temperature, weekday, your hunger, thirst, and overall productivity. And of course your emotional state at that given time for the AI to compare. When running the program, it will ask you about each of those infos except the emotion, that's what it has to predict. After giving the AI all those infos, it will tell you emotional state that it thinks you currently are in. So basically the AI asks you what's the weather and if you're hungry or if you're thirsty or if you're productive and stuff, and based off the old data set that you gave it, it will predict how you will probably feel. So I just thought I show you this here on the desktop real quick. It's faster than animating everything, so this is just much faster. Ignore all those files on the desktop, I'm pretty unorganized right now. Downside of if you do video editing and coding and whatnot. So basically we have saved models, which is just basically the network being saved every time I retrain it. But it retrains every time you run it anyway, because right now it's not big, so I can just retrain it really easy in a few seconds. Then we have a bit of dataset info, which basically just tells you what numbers means what in the dataset. Because if you look at the actual dataset, you probably don't really know what means what. Basically it records the order of the times you recorded something. It's not daily, you would need to run the script daily, then it would be daily. It records the weather, temperature, weekday, your hunger, your thirst, your productivity, your actual emotion that you gave it after it predicted, and the actual AI's prediction. Basically keeping track of the actual emotion and the AI prediction to make graphs and compare and stuff. So the code is pretty much open source. I'm thinking about actually turning this into a little program with an interface that you can use to just press simple buttons, and then you can have your own prediction model, really easy to use for you, because this is just all hacky and you need Python installed and you need to know how to use the console and everything else. So running this initializes Python and then asks the few information that it wants from you. Basically, what's the current weather? Right now it's sunny, so it's great, so 2. The current temperature is, I think it's normal, it's not really hot. The current weekday is Wednesday, so 2. I'm not hungry at all, so it's normal. I'm not thirsty, and my productivity is, I guess, 1. I'm not being lazy right now, but I'm also not being super high productive, so just 1. Then the network runs, it retrains, or not, it's getting an error. Great! So this thing just trained in a split of a second. As you can see, it's just 5 epochs. I could do way more, but I don't really think the network would become better. So basically, it guessed I'm feeling good based off the dataset, which is actually correct. Then it shows you the table view, which is basically the 5 new ones as output. This is neuron 1, 2, 3, 4, 5. And as you can see, the best neuron didn't fire at all. The second best, the neutral one, the neutral emotion, didn't fire at all. The worst one and the bad one, like the emotion worst and bad, fired a little bit. And the one with the biggest score was good. So it basically just tells you the emotion that's the biggest score in this list, which in this case is this one with 0.7, which is the emotion good. So it tells you you are feeling good. Then I ask you if the prediction is correct. If I type yes, then it will just save this all. If I type no, it will ask me about my actual emotion and then save it to the dataset, which I can actually show you real quick. Dataset, if I type yes, it applies a new list, which is just all the information, like the new order, the information that I just typed, the actual emotion and the AI prediction. Both numbers are the same because the AI was correct. Now the reason why I'm actually saving the actual emotion and the prediction is for plotting, like a graph, to actually see how it's doing. So basically it goes to the x-axis through the days, the y-axis for the emotion, the red line is the real emotion, the blue line is the AI prediction. What you basically want is the lines to be exactly synced. Right now they are pretty much fucked, because the AI wasn't really able to predict that great, exactly, especially in the beginning. It was really bad with such a small dataset, but the more I use it, the bigger the dataset becomes, the better the AI will be. Do you see a problem here? I definitely do. In order to have the AI predicting your emotion, you need to feed it with infos about weather, hunger, weekday and so on. But what you and I want is an AI that simply tells you your emotional state in the near future. You don't want to tell it about the weather and so on every time. That also means, which is the key point, that if you want a prediction about tomorrow, you have to guess what the weather, temperature, hunger, thirst and productivity will be. And that is just not the kind of prediction I planned. I definitely will learn about time series data prediction or regression at some point, but so far this is what I did with my knowledge. Also, in case you want to know, I use Keras sequential model with a neural network with 1 hidden layer with 32 neurons. It's nothing advanced, it's just a simple classification network. Really simple actually. Okay, now that we went through the AI project as well, we finished all of my recent little scripts. So we are done for now. Thanks for watching. The next video will probably, hopefully, be about Andrew and my big project. Because that's actually really cool and something helpful, something you can use, something we can use, which is just, it's just great, but I'm not gonna tell you what it is, because as soon as I do, you will basically know every single thing about it. So it's gonna be secret, but we will see. Really hope we get this finished soon. If not, then fuck. But until then, see you around. Bye.